whole class.
Hello.
How y'all doing?
All right, you.
All right, all right. Many people got 6 people on. Anybody with any questions? How my program? Oh, what you got? I'm listening, Mr. Law.
Chapter 4, program 1, when we had to output the I'm drawing a blank. It's we had to output these certain column widths.
Yeah.
I had trouble with one of them having it a specific set width of 15 on the ones that needed a on the top one specifically. The top one I could not get to line up properly with a set width.
You talking about the column heading?
Yes. The column width and the I can pull it up right quick and read it to you.
Which program that dealt with? The payroll?
Chapter 4, program 1. Loan payment, insurance, gas, tires.
Yeah. Because I think the first column was the different items, itemized list. Then the next column was the dollar amounts.
Right, and I for some reason I got it correct on every other dollar amount, but the very first one, the loan payment dollar amount, I had to set it to a set width of like 13 instead of 15 to make it line up properly with the rest. I couldn't set it to a set width of 15 like all the others. I couldn't figure out why.
Because I think that information was aligned to the left, right?
The left column, the left column for loan payment, that information, I meant like I misspoke. I meant like the numerical dollar sign information.
Now that was aligned to the right.
Yeah.
And you should have had 2 decimal places. So the 2 decimal places should have fit to the right, and all of them would have been even.
Yeah, like I said, it did that for every single one except the top one, which was loan payment. I couldn't figure out why I did it. I meant to leave a comment in the program before I submitted it, but I figured I could just ask you, see if maybe it was something weird I did wrong.
It depends on when you specified the set precision and fixed. You did it before you start printing out anything?
I set the precision to 2 and fixed before everything.
All right. And then you set your column. Then you should have had, no, not a loop. No, not a loop. Yeah, you output. When you output the loan payment, you should have had a set width, left set width to 15, and then loan, and then stream set width, set W to 8 or 10, what it was, and then the dollar amount. Now, another thing you could have had, may have had a space that you was outputting in between it or something or whatever.
Okay. I might have to look back over it.
Yeah, if you did like double quote, but nothing is printed. Yeah, gotcha. You add that space in between now or something. Yeah.
Okay.
It could be that. Yeah. Yeah. Anybody else? And I could go back and look at your program too. Anybody else with questions? Now, I got I talked to one of your classmates during my office hours, and I saw some people, about 5 or 6 people, hadn't turned in 3 and 4. Well, no, what it was, 2 and 3 or 3 and 4. Well, anyway, the last 2 assignments. So I just went ahead and extended those for a day. All right.
Okay, thank you. I had that same problem.
Oh, okay, yeah. So I just extended it for a day. Give y'all today and tomorrow. I think I did it for tomorrow, but make sure, I think it's today and tomorrow at 11:59 tonight. Yeah. All right. So go and try to get them done though. And like I said, most times I will answer a question, but I won't directly answer the question. And what I mean by that is, I won't just give you the code to write to get it right. I'll do like kind of what I did just now. Say, well, maybe you're doing this, or maybe it has this, or maybe you done this, so that you can go back and kind of think through it. And then once you get it, it's like, oh, okay, I got it, I got it. But if I just give you the answer, it's like, oh, he just gave it to me, it worked. And you don't really know why or what, was done to get it right.
I did have one more question, if you
What
don't
you
mind.
got?
So the quizzes that were posted to do on October 4th,
Yeah.
um, I completely overlooked one of them. I did the relational operators, I did the solo learn, but I don't know how, but I completely overlooked chapter 4, quiz 4.
Oh, that with the what it is, those numbers and stuff, huh?
I did the relational one, but I don't know how I overlooked it. I was going to see if there was any way I could still take it. If
Yeah. Now I'm gonna tell you. Now a lot of people ask about the question, another question about the test and the quizzes. What I do is at the end of the semester, I do give you an opportunity to take whatever test quizzes you missed in
Okay,
that
awesome.
last week of school. You know what I'm saying? So it's not lost, But if some people they be pressured to say, well, I want to take, can I take it? And sometimes depending on I'll let them. But for the most part, the last week of school, what I'll do, I'll prep you. I say, look, I'm gonna put out a practice test. Uh, from this date to this date, I'm gonna open up all tests, okay, and give you that one extra opportunity to take it. All quizzes give you that one opportunity to take it, and so you need to set your times to where you can take them, and then hopefully you could take them. Because what, like I say, I do that because most times a student, and I've done it too. The bell goes off once you get to the next semester. I mean, not the next chapter, and it's like, oh man, oh, this is how this works. This is how this works. But you done took the quiz and you done took the test, but it's like you can't go back and rectify the problem. So at the end of the semester, as we learning, at the end of the semester, I'm gonna let you just say, okay, show me what you know. Take all the tests, and like I say, hopefully you could do better if you hadn't already. And now you're giving me exactly what you know. If you had problems with the if statement and didn't quite understand it, and then by the time we started dealing with ifs and whatnot, and it's like, oh, I got it, but I done took the test now, I can't go back. You should retain it, and at the end of the semester, you should be able to go through that test, chapter for whatever test, and say, "Oh, okay, I know about the if statements. I know how this works, whatever," and make a great grade on it. So I do give you that opportunity at the end of the semester.
Awesome. Okay, I appreciate that. Thank you.
All right. Okay. Any other questions? Questions? Because midterms now, that's another thing. The only thing, some people, what they'll say is, "Well, my midterm grade or whatever," and like I say, nephew, that whatever about your midterm, then sometimes I say, okay, you could go ahead on and take it, and your midterm grade will be whatever. It might boost it up to be whatever. But midterm grades are not really recorded as being a permanent grade. Midterm grades is just so that you, as a student, will know somewhere where you stand in the class, rather than just being in the class from the first day to the last day. And it's like, oh well, I didn't know I was doing that bad. I could have dropped the class, or I could have did whatever to do, what I needed to do. So that's pretty much what the midterm process is for, to kind of make sure you know where you stand and what it is you need to do. You need to bump it up, or you need to say, well, I'll let this go, and next semester I'll pick it up or whatever. All right. Any more questions? Other questions? Questions? All right, because we was in, I think, what chapter it was? Not here. I think we was in chapter 4, I think. And I'm on the wrong computer because my other computer had to reboot. So I need to download something. Let me download it. Well, no, I might have it. I might have it. Where is it? I need to find. Nope, I don't have it. Oh yeah, here we go. So I do have it. So it's the same book. Let's see, chapter 4. What's going on? Here we go. Gonna get locked up. Hold up, Claire. And you can't see my screen yet, huh? I'm gonna have to open up my screen. Hold on. Okay. Let me go to Zoom and share my screen. Okay, all right. I think it was in chapter 4. Now I'm gonna have to scroll down to chapter 4. Okay. 7 up. 5, 6. Yeah, that's right. Is it 5? We're in chapter 5. I think this what it was. Yeah. Oh, no. Yeah, we need to do this. We didn't go over scope. All right. What were in chapter 4? I think we did 4. Yeah, we didn't go over case statements and switch. Right. All right. So let me try to get to where we were. Okay. We kind of talked about that scores. All right. So we stopped somewhere in the long lines of here, line of here, and we talked about how numbers are actually inputted by a numeric value, the ASCII table. So we kind of talked about that. We did the chart, and we kind of talked about it. But that's the chairperson calling, but I gotta save him class. Just tell him. Yeah, I'm in class.
Oh, all right, bye.
All right. Oh, let's see. I want to go back up a little bit more. Go back up. Yeah, okay. I'm gonna kind of talk about the menu too, because we need to and or yep. Because I do have an and or quiz. All right. So this pretty much where we kind of stopped off up in here. All right, what the ifs, right? So then we caught, let's say, catching the errors when we did the grade, everything greater than or equal to 60. But if it's less than 60, then they got an F. But if a score was put in less than 0, you have to have had another condition to ask, so that you can know that an invalid score was put in, like a negative number. All right. So we talked about flag. Okay, a flag is a boolean or integer variable. All right, now we talked about them, but we talked about them earlier because we said what an if expression yields true or false, 1 or 0. All right, so in this expression here, if sales greater than or equal a quota amount, what's going to happen is the compiler going to evaluate this. If it's a 1, which is true, is going to perform the true logic. If it's 0, and then it'll perform the else logic. All right. So, and look what happened. What they did here, they set a Boolean value for sales quota met to equal a false, but they used sales quota met. They said, okay, if sales quota met, if sales is greater than or equal to a quota amount, that sales quota met equals true. And notice it's just no double quotes around it or anything. It's a Boolean value. It's going to be 1, 0, true, false, yes, no. All right. So you don't have no quotes around it. All right. Then else, if this doesn't hold true, it's a 0, then this would be false. All right. So just showing you how you can write code using with the logic, understanding that if this doesn't hold true, if this holds true, it performs this. If it doesn't hold true, it'll perform the else. All right. So it tells us integer variables, okay, may also be used as flags. All right. So remember we had we had true and false. Now they're using 1 and 0. See, Boolean value could only be true, false, yes, no, on, off. All right. So now same exact statements. If sales is greater than equal to quota, then sales quota equal 1. All right. Then else sales quota met equals 0. But what? This time they set it as int. Before it was a Boolean value, true or false. Now it's a number, 1 or 0. Okay. So that can be done. But in computer science, most, I want to say, issues or problems that we are programming have a multitude of conditions, a multitude of if this, do this, else do that, or if this is greater than this and that's greater than that, do whatever. So that's where the logical operators come into play. All right. Now you say, well, Mr. Vessel, why would we need logical operators? It's so that you can compound your if statements, all right, or a while statement, which we'll get to in the next chapter. But say, for instance, you wanted to write a program that wanted to check to see if something was equal to 2 or more values. So rather than write if x is equal to 5, else if x, or then another nested if x equal to whatever, then another nested if else equal to whatever, you could say if x is equal to 5, well, no, and I do and, but right here you would use an or x is equal to 10, or x is equal to 15. So now you got one if statement, but it got an or in it, where it could equal to 5 or 10 or 15. So what you did now in one statement, I'm checking to see if x is equal to 3 separate values in one simple statement. And if it's true, bam, you want to do whatever statements. All right. So even with the and normally with the and, you could do the same thing with the and, but like I said, not with numbers, because how can something equal to 5 and equal to 10 and equal to 15? But with and, what we could say is we could do a range. If we were dealing with, say, body temperature, all right? Say normally, and I don't really know a lot about a doctrine, but let's say a normal body temperature without being sick can range from, say, 95 to 100. Okay, so anybody with the body temperature equaling a 95 or 100 would be good. What you could do, you can write code and using that and logic to say if body temperature is greater than or equal to 95 and body temperature less than or equal to 100. So what you've just done, you've just checked for a range of values. If the body temperature is 95, 96, 97, 98, 99, or 100, then you could say the person is doing well, or whatever it is you want to put. Else, if it's too low, they could be sick, or whatever, or anemic. Or if it's too high, they could have a fever and maybe need to go to the doctor or check to see if they got the flu or whatever, or however. So you see how that those operators can be used so that you can compound your if statements, so you won't have all these different if this, if this, if this. You can ask it all in one question. Now, if you look down here, you see the not. The not kind of do the reverse of an expression. Example, if I say if x is greater than 100, all right? But then if I put a not in front, if x not greater than 100, now I'm checking for everything that's less than 100. So I just reverse my logic. You understand? So that's what the not does. It just reverses the logic that you have in the expression. All right? So let's look at the and it shows us that the and operator is known as the logical and operator, which is the ampersand, ampersand. All right? So it takes two expressions and as operands and create an expression that is either true or that is true only when both sub expressions are true. All right. Now, let me see if they have the they have the table here. Look at this. This is the truth table. So what it's saying is, if I have an expression and another expression, if both sides are true, then it will do the true logic. If one side is true and one side is false, it's still false. It's going to do the false logic. If one side, the A side is false and the B side is true, it still do the false logic. And if both sides are false, it still do the false logic. Now let's look at an example for that. So let's y'all never did arrays yet. So let's do this. Let's say something like this. Int say x equals 25. All right. And then we say y. Well, I'll do it like this. Int x. All right. Then I'll say cout enter, and we'll do temperature, like the example that I gave. Enter I can type enter body temperature. All right. Then we'll do a cn x. So now we're gonna read in a body temperature. Wait, what's going on? My semicolon. All right. So we're gonna read in a body temperature. Okay. So once we read in that body temperature, remember we said the valid temperatures, and that's just our little scenario, is from 95 to 100. So in order for me to write that one statement that'll compare and check to see if the input is between 95 or not between, starting at 95 and ending at 100, I would do something like this. If, and then my parentheses. Now, we know that X is the body temperature that we read. That's the value. Now, I can say I could change that to temp to make it more realistic in what we're doing when we write the program. I'll say B temp. So say be ready for body temp. So now I have to read in B temp. All right. So now, here I'm going to ask if B temp is greater than or equal to 95. Now, if it's greater than or equal than 95, are we well? No, because what? A temperature of 104 is greater than 95. But man, you're kind of sick when your temperature is that high. So what's the range? If it's greater than or equal to 95 and less than or equal to 100. So now, if it is I messed up. I have to use the body temp on both sides, B temp, because you got to know what you're comparing against. So this would be the A part, and this would be the B part. And notice I had to have this compared to this and this compared to this. I can't just say a body temperature greater than or equal to 95, greater than less than or equal to 100. Can't do it. Got to have an A and a B and a comparison, A, B comparison. So if I put in, when it asks me, if I put in 99, it's going to be good. If I put in 105, not good. If I put in 88, not good. So you understand what's happening. So I'll say, I'll just do this, and I'll say, okay, if it's greater than or equal to 95 and less than or equal to 100, okay. See how, and I'll just you are well. All right, something like that, whatever. You know what I'm saying? All right, but then else, if that doesn't hold true, that means it's less than 95 and or greater than 100. You know what I'm saying? So now what'll happen is I can put my else condition and I say, whatever I put, whatever it is you put. All right, so we have this code, all right? So let's run the program. I should have made it loop, but let's run it. Okay, hopefully I got it logically correct. So we run the program. All right, so let's move this over. Inner body temperature. We're going to input a temperature. If that temperature is between 95 or 95 and 100, then should say you are well. So let's put 95. 95 should be included because I said greater than or equal to. Hit enter, you are well. So you see, but if I run it again, okay, I could still put 98, okay, you are well. But when I go in, and if I put any number outside of that range, and I put like a 82, okay, you need to see a doctor. All right. So even if I go in, I put 101. All right, let's see. And I put 101. You need to see a doctor. So see what happens? Everybody understand what happens? That and allow me to check for a range of numbers from 95 all the way to 100. I don't have to say if it's 95, if it's 96, if it's 97, if it's 98, if it's 99, if it's 100. No, if it's 95, greater than or equal to 95 and less than or equal to 100. All right. So now, and then there's some things you can do to exclude the 95 and 100 by making this less than or equal to 95 and greater than or equal to 100. Now you just excluded a 95 to 100, but then your logic here would change too because if I change this logic here by saying if it's less than or equal to 90, well, just say less than 95 because the equal to is a part of it, or greater than 100. I have the same logic, but then now my true is here and my false is at the my true is my false and my false is my true. So I'd have to cut this and put this here and then take this and put this here. Now, so I changed this to less than or greater than, but I had to also change this because now I'm checking to see if the temperature is less than 95 and greater than, well, it can't be both. I have to use R. And this would be R, right? Or it'll be the pipe symbols. All right, so what happens is, now to exclude it, because a number can't be less than 95 and greater than 100 at the same time, correct? So what happens if a number is less than 95, no matter what it is, or if it's greater than whatever that number, greater than 100, no matter what it is, it's going to say you need to see a doctor. Now, remember with and though, let's go back. Both sides had to be true. If it was greater than or equal to 95 and less than or equal to 100, it was true and it did this. Now, if it's less than 95 or greater than 100, it's going to do that. So now the R says, if this is true, go ahead on and do this. But if this and this is false, still do this. One of them need to be true in order to do this, or both. But then if this is false, but this is true, it'll still do this. Okay? But if both of them is true, if both of them is false, if it's 99, if it's greater than 99, 95, but then less than 100, then that's gonna do you well. So let's run the logic. All right. So here we go. Let's put 93. That's less than 95, right? So what? It was less than this. Now, is 93 greater than 100? No, but we use R. This side held true, and this was false, but it's still what? With R, only one side need to be true to perform the truth. All right? So let's run it again, and this time we'll put like 97. All right? No. And we'll put 97. And it should say what? You're well. You see what I'm saying? So what? What happened is temperature less than 95? Nope. Is temperature greater than 100? Nope. So that's false and false. False and false says, okay, do the else part. You are all well. So, and what I'm trying to show you is when you're writing code, there's more than one way to accomplish a task. It all depends on how you think. Some people think asking questions in a negative way, is easier for them. And some think asking in a positive way is easier for them. Because what? You saw where I wrote what? If B temp is greater than or equal to 95 and B temp less than or equal to 100, it works. But then we changed with the R. If B temp is less than 95 or greater than 100, then we do one, then do the other. So, like I say, it's all in how you thinking it, all right? So when you look at somebody else's code, don't be afraid and like, oh, well, they did it this way. But if your logic, the way you thinking is on a different side, it could be right. So and like I said, it's all programmer style, so like I say, don't be afraid. So now, anybody with any questions? And I know I went to the R before we completed the and, but like I say, look at this. If temp greater than 0 and less than 100, you cannot do that. You got to have temp greater than 0 and temp greater than 100 or some other variable, whatever. But you got to have a value, operand value, and value, operand value. All right? So numeric operand. Now, which is this, temp greater than 0 and temperature less than 100. All right. So now, looking at this program here, what they did, they combined, they got an and with the employee, whether or not they're employed and recent grad. Because previously, in our last lesson, they had an if statement, then they had another nested if statement. But look what they did. They asked both of the questions in one statement. If employed, okay, that's true. I'm saying if it would be true. And recently grad, if that was true, you qualify for a special interest rate. All right. So you didn't have to do that extra indentation and all this, the curly braces or whatever. Right. So if these two things hold true, you perform this. Else, you perform this. Now, the only thing about that is when you look at this, you don't know which one disqualified them. So in your prompt, you have to tell them they must be employed and have graduated from college in the past 2 years, because this is going to check for both. And if neither one holds true, when you go to your else, you don't know which one doesn't hold true. So that's one of the downsides of that. All right. But you could, like I say, in your prompt, in your message, you tell them, both of those has to be true in order to do whatever. All right. All right. The operator R, and we went over that R. So look here. If temperature is less than 20 or temperature greater than 100. So what you're doing, you're excluding the range 20 through 100. All right. Anything that's 20 and anything between 20, from 20 to 100 will be in the false condition. All right. Would be for the false logic. All right. So you can turn your logic around. It says the OR operator is known as the logical OR operator. Now, notice you see just two lines. If you look on your keyboard, right beneath the backspace key and right above the enter key on most keyboards, you see the backslash, and then there's a line, and some of them it's a line divided in half. That's the pipe symbol. But it's two of them together. So when you hold the shift key down and you press that twice, that's the R. Okay. So that's the symbol for the R. All right. Now, it should. Okay. Now with the R again with true, remember both sides has to be true for it to be true. Otherwise, everything else is false. With this, any side can be true or both sides can be true, and it will be true. But if both sides are false, then the expression will yield to be false. All right. So looking at this, if temperature is less than 0 or temperature greater than 100, if this side is true and this side is false, it's still going to do the true part of that if. If this side is false and this side is true, it's still going to do the true part of that expression. If this side is true and this side is true, obviously it'll do the true part of the expression. But if this is false and this is false, then it'll do the false side. That's the only time it'll do what the false expression. All right. So it tells us all it takes for an OR operation to be true is for one sub expression to be true. Right. It doesn't matter if the other expression is false or true. If any one of them is true, then it does the true. The OR operator also performs short circuit evaluations. If the sub expression on the left side of an OR operator is true, the expression on the right side will not be checked. So what? It saves time, because once you find out that the first side is true, you're just wasting time to check to see if the other side is true, because what? Either one can be true and it's going to do the true. So it just check that side and move on if it's true. If it's false, now you got to check the other side to see if it's false or true. All right. So that's all that's saying in that part. All right. So the same program again, dealing with annual income and a loan. All right. So again, now it asks, it asks if income is greater than min income or years greater than min years. So now, rather than doing the and, remember the and portion. What is that? Here. So what the and did, it asked if employed was equal to Y, all right? And grad year equal to Y. But in this one, now it's dealing with an amount where you enter an amount if the income is greater than or equal to the minimum amount, okay, anything from that above, or the year greater than the minimum years, you qualify. All right. So, but in this one, any one of these hold true is true. Right. So it's a little bit different from the other one. So if this is true, it's gonna perform, you qualify. So if the income is above the min, it qualify. If the years is greater than the min years, they qualify. All right. But you got to understand with this one, if the minimum income, like say they just started working and they're making lower than the minimum income, but they have, when I say just start working, but then they have so many years, then they still gonna qualify. Right. So see, it kind of changes it up a little bit. But then it say you must earn at least minimum or have more than whatever years. Because remember, I told you when you're checking for two here, when you go to the else, you don't know which one made it trigger to be false. So you have to put the explanation for both of them. All right. And that's dealing with R. So you got and R. And all a not does, it take a true expression, turn it false. We never did the in the file yet. But with the R, but look here, just give you an example. But when we dealing with like say not true or not whatever, I could say not X greater if X greater than 5. Then I could say if not X greater than 5. Okay, so anything outside of 5 will make it true. But if I say if X equals 5, then it's going to only be true when X is equal to 5. All right. But it tells us here, looking at this, all right, the not operator performs a not logic, a logical not operation. It takes an operand and reverses its true or falsehood. So if it's true, it turns false. If it's false, it turns true. All right. In other words, if the expression is true, the not operator returns false. If it is if the expression is false, it returns true. Okay. And here's an example. And I'm gonna read it without the not first. This would say if temperature greater than 100. That means anything greater than 100 would be true. But when you put the not in front, if not temperature greater than 100, that says if you have a temperature where it's not greater than 100, anything from 99 and below would be the true part because you said the not. You know, this is asking this, but then it say not, so it's reversing it. So now it's changing this false, this whatever's here, whatever's true to false, and your false to true. Right. So temperature greater than 100. If I put in 99, by normal standards, it would be false, but this not would make it true. All right. The not would make it true. Any questions about that? Any questions? So that's all the not does. It just take it and returns it to be true. So look here. Now, this is for this entire expression. You evaluate the expression. If it yields true, then you do the not, it's false. So if income is greater than or equal to min income or year greater than min, say years was 20. So that would make, then say this was false and it was true. That would make this true, but then this would turn it false. You understand what I'm saying? So we do the false logic, all right? So that will make it false. So that we do the false logic, all right? So that's how the not operator works, all right? And then it showing the precedence. Precedence, the not operator as the precedence. Then you have the and or, on the same level, all right, of precedence. Now, so here, x greater than 2, not. It reverses whatever this is. Not x, it reverses this, because this is dealing with the x and greater. Well, no, it would do the x greater than 2 and the not. So it's the same, all right? Let's see. The first expression applies not operating the x minus 2. X is not greater than 2, okay? The second expression, however, the not is only on x. So yeah, my fault. So not x. That means x not 0. If it means not x. Anything other than 0. So if x is 0, it would be true. all right? But if it's 1 or whatever, it'll be false. So if X was equal to 5, then this would turn this to be false. And then it would check. So, and we'll like say 0 and 1. So we're doing the expression of 0 and 1. So what happened is it is asking, is the logical negation of X greater than 2? Okay. Suppose that X is set to 5. Since 5 is non-zero, it would be considered true, so that the not operator would reverse it to false, which is what? The 0. All right. All right. Then there would be the greater than operator would be determined if 0 is greater than 2. So that's here. So if this would be 5, okay, not X. No, it's not X. Turn it to false. And then 0 greater than 2, no. All right. But this compares it by grouping it, X greater than 2. If X is 5, 5 is greater than 2, that would be true here, but then this would turn it to false, the not. Okay? All right. Oh, skip. Okay. So here we got A greater than B and X less than Y. Okay? So all this would be the same because what? This has higher precedence. This precedence here, you're going to do what within here? Well, within here. Same thing here. This would be done before this is done. All right, so this is done. This is done. Evaluate, and then do the and. Here, evaluate, and do the or. And the same here. Evaluate, and then do the or. All right. But like I say, most times you want to put your parentheses so you know exactly what you're comparing and whatnot. Because you can have multiple. So look what happened here. So you got this or this and this. So what you'd have to do here, you'd have to evaluate this, then you got parentheses here. So then you evaluate this and this, and then whatever you get here, you evaluate this, then it will be this or that, true or whatever, or false or whatever, or false or false, whatever it is. All right. So we also went over checking a range. We did that already where we had 95 and 100. Looking at this, if X is greater than 20 and X less than or equal to 40, what is the range for that? What is the range for that value? Anything valid or true would be what? 20, 21, 22, all the way to 40. Correct. So if you wanted to check a range, all you had to do is what? Know what values to place inside of here, greater than equal to this, and less than equal to that, right? So that's how you would check a range, right? But then sometimes you want to exclude a range, all right? You may want to exclude certain portions of a range. So that way you would do if X less than 20 or X greater than 40, which is some of the two examples we did already in that program we wrote. So when you do the or, you want to say if it's less than 20 or greater than 40. So anything going 20 and below, and anything going 40 and above, invalid. All right. All right. Well, you asking it, this gonna make it true, and then it tells us that the acceptable range. All right. All right. Anybody with questions? All right. Because like I say, the expressions here, you got to know how to evaluate this. Looking at this look like a lot of just symbols. But if you look at it, you'd have to start evaluating this expression from here. You could start here. You could say, okay, it's A greater than B, and that'd be true or false. So you put a true or false. So say we put a false here, right? Or, because if it was true, then we wouldn't even have to do this, correct? Remember we said with the or, once it finds the first part to be true, it disregards the second part because it's irrelevant. So if we find this to be false, but then we do this, y equals, if y is equal to z. if this is true, then now we need to check this. If M is greater than J, if this is true, true and true yields true. And then what? False or true yields false because it's or. So the and was for these two, but then the or was for this in the evaluation of all of these. All right. So you gotta make sure you know how to break it down. All right. All right. So and this just showing you, like I said, we did the ranges. You could do ranges and whatnot. All right. And like I said, again, this is the table. True and true yields what? Well, this true and false. True and false yields what? Anybody?
True.
False. Oh, false. Because and. You understand? If I say A and B, I'm talking about only one of them or two of them?
Two.
Right. So if something yields to be true and false, it's false. What about this? True and true?
True.
True. False and true?
False.
False. False and false?
False.
False. Now, true or false?
True.
True. I say or. If I say A or B, either one, it doesn't matter. True or true?
True.
True. False or true?
True.
True. And then false or false?
False.
False. But what about not true?
False.
False. Not false.
True.
True. So you understand that's one of the little end of the chapter exercise, but that's what they're trying to get you to understand, as those things like that. All right. Okay. Now, menus. Menus can be used to help you write code, especially if you're writing code when you're dealing with menus or whatever. I mean, sub programs or whatever. You know, menus can be very helpful. All right. So with a menu, and if we look at here, and what I'll do, let's create a menu. Let's take this program here, and what I'll do is I'll take this out. And what I can do, let's just write a menu. Let's say we do something like see out. And I'll do I'm gonna type. All right, I'll do a main menu, and then, oh man, why? All right, and then normally with a menu, you can kind of decorate it or whatever. Then I didn't put my semicolon. All right, see out, and however, and I'm just putting this here, I'm gonna put /10. All right, so all I'm doing is trying to design a menu that will somewhat represent what I'm gonna have the user choose from. All right, and what I can do here, okay, semicolon. Okay, I did it. Now, then I could do see out. If I could type my computer. And I'll do something like /n/t, and I'll just go over and I'll say 1. And say if I had something to where I'll add numbers, all right? You know, and like I said, this menu could be whatever. It don't have to be something like this. Whatever it is that you trying to portray for the user. What is this? How did I get to this? How do I get out of this? Oh. Where is this? All right, so here we go. 3. Multiply numbers, and I'll just add another one just to show you somewhat of what a menu could look like. But like I say, you'll be the one that designed it. I forgot my T up here. All right, and I'll say 5, quit. All right, so this is a menu. Now, normally, also what you may have is something like this. And then you might have inner choice here. And whatever value you're reading in, I don't have it, but I'm gonna have to do something. All right, but that's just some see-out statements. But what I might have something like chore, or say choice. All right, and then all right, but so and I'm gonna run this, and all it's gonna do is show a menu. It's not doing any logic or anything. Or it should show it. Hopefully, it show it to you. All right. So look, this is just a small menu that just created, and it's like I say, it can give a user a better directions as to what to do. Is in a listing. I could choose 1, 2, 3, 4, or 5, and whatnot. 1, I could make it call a function to add numbers. 2, I could call a function to subtract numbers. 3, I could call a function to multiply numbers. And 4, I could call a function to divide numbers. And 5, I could call just exit the program. All right. Now, like I say, add numbers, subtract numbers, multiply. That could be any type process. It don't have to be just add numbers, whatever. You can have, let's just say, number 1, function for students to input personal information. Input your name, address, whatever. The next option could be to print student information or whatever. So it don't have to be just something add whatever. So this a menu, and when you put a number in, now it's just gonna quit. It ain't gonna do nothing because I don't have it doing anything. But that's an example of a menu. And when you do a menu, like I say, what I can do, I'll do it right quick to show you because I'm telling it to you, but I'll do something like void add, okay, add num, okay, and I'm not passing anything. Then I could go to down here and I could say void add num, and I'm not passing any value. All right, and create my function. And then here I could say, int x, y, z, whatever. Then I'll do cout first number. And the first number will be x. Okay. and then see out. All right, second number, and then Cn Y. All right, and then what I can do, I'll go back up here and make this sum, so it was understanding. All right, then I could do down here, I could say, okay, sum is equal to x plus y. Okay, and then see how, whatever. Sum of x and y is, yeah, I don't do this, is, and then, oh no, I need to add, where am I? Is, this keyboard, y is, and then I'll put sum. All right, in line. Okay, so that's the end of that function. I got all this down here. Let me take this up. Oh no. Okay, close this. All right, so that's this function. So we're gonna go in and do this and write out that, and it'll finish. So calling that inner choice. But then I have to do something like this. If, because I can't just put it down. If choice equals 1, right? Then I can say, I know I'm gonna do the double quotes. Then I'll do add num. And what that does, we never went over it yet. We'll get to this toward the end of the semester. This is a function which is defined down here. It'll call this function, execute it, and return back and end the program. So let's run it. Now 2, 3, 4, 5 is there, but 2, 3, and 4 doesn't have anything associated with it, so the program is not really fully ready yet. But I'll run it, and then what? When I put in 1, it should do what? See, in a first number. Where did that come from? That came from what? This function down here. That came from this, in the first number. I should have put another space, and I should have put a space here. Should have put a space in tab. And I should have did the same thing here. But that's just cosmetics. But let's go back to it. In a first number, so I'll put in 12. In a second number, I'll put in 10. So 12 plus 10 is what? It's 22. So when I hit enter, see, the sum of 12 and 10 is 22. So see what happened? It executed that in the program. But normally what happened, you'd have a menu and you'd have it in a loop where you'd allow them to stay in that loop as long as they enter something. So they enter a choice. When they enter a choice, they stay in that loop and come back, enter a choice. So they'll stay in there until they enter 5 to exit out. As long as they enter a value, they enter that value, but then they stay back, go back and execute that loop, prompt them for whatever, and they're gonna stay there until it exit out. All right. So that's menus. So in this program, so I did all that to show you this. In this program, you have Health Club membership menu. Then 1, standard adult membership. 2, child membership. 3, senior citizen membership. And 4, quit the program. And then look, enter your choice and see a choice. Basically, the exact same thing. You can have a whole list of choices, 1 to 10, 1 to 20, whatever it is. your menu, however you want. Or you could have one menu, go to another menu, because you could have a menu to say print items or print records. And then you go to a print screen where it might say just print name and address. Or one say print name, address, phone number. Have a print menu where you can choose what you want to print out. So like I say, you as a programmer, you would be designing stuff. Most time you'll get the specs from people above, but then you'd have to write the code to fit what they need. So they have their menu. Okay, once they have their menu, enter your choice. Once you enter your choice, look here. If choice is equal to adults, but then what they did here, they made a constant value of adults to equal to 1, adult choice equal to 1. So if it's 1, it's going to go to adult choice, 2, child choice, 3, senior citizen choice, and 4, exit. So if choice, if we put in 1, is equal to adult choice, which is 1. So if we put in 1 and it's equal to 1, it's going to output for how many months, put in the months, then charges is equal to months time adults. And somewhere they declared adults to equal to a certain amount. So it's $40. So you understand what's happening. So they created a menu, and then from that menu, they had if logic to determine what they want to do at what time. All right. So that's writing it with a menu. So look here, this is where they ran the program. This is their menu. This is the heading of the menu. This is the menu choices. Okay, they entered the number 3 and press enter. It say for how many months? 6 months. So 3 was a senior citizen membership. All right, and that's what's $30. So 30 times 6 is the 180. So that's how that program works. All right. All right. Now, focus on software engineering and then validating user input. Because as you start working with in computer science, you're going to want to start to validate your input, right? And you say, well, Mr. Vessel, why we got to validate our input? When they put in whatever, if they put in 5, the computer going to do whatever. Okay, give an example. Sometimes, just sometimes, or you may have experienced it with the C++. If you tell somebody input an integer value and they put in a letter, the computer, the program blows up. In a sense, it just gives you all kind of erroneous data. And what happens most time, what people would do, they'll tell you to input the data, and they'll read everything in as character data. Then they'll test that character data to see if say if they want to input an integer, they want you to put in a number like 500. They'll declare the variable to be inputted as character data or character array or a string. But anyway, they'll take that data and then convert it and check it to see if it's all numeric. You understand? So that the computer the program won't blow up. So it allows you to read it in as that character data, and then it checks that character data, check to see for digits, because there's some functions in C++ where you could check each individual character of a string or whatnot to see if it's a digit, if it's a punctuation, if it's a alpha, which would mean a letter, if it's a non-printable character, a space, or whatever. So you can validate all that. And that all that's not done here, but normally if you put in a test score, if you put a test score of a -5, -5, that's invalid. So you're gonna have to check, whatever, and then if it's less than 0, then it's invalid. Also, if you're a teacher and all your test scores are 100s, you don't give bonus on tests. So if somebody put in a 105 or 120 or 110, then you know that something is wrong, and you should be able to check and validate that so that you won't, to verify the integrity of your data. All right. So saying all that, it's like As long as the user of a program enters bad input, the program will produce bad output. And that is just as anything. If you learn bad things is what you're gonna do. Programs, if you put in bad data, now some data it can't validate. And what I mean by that is, if it asks you, and you've done it probably many times when you register for things on the internet, what is your first name? You put your brother's first name or you put somebody else's first name. It can't validate whether or not you are that person, but it can validate whether or not what you put in is characters for a name. You understand? So that's what you validate. That other part that comes in after a while when the system is running, somebody comes in and say, "Oh, I'm so and so, and I registered with you. My ID number is whatever." Well, what's your name? Oh, your name? No, the name we have is different from whatever. And then that's when you have to go in and try to fix the data. All right. So perhaps the most famous saying of the computer world is garbage in, garbage out. As simple as that. You put data in that's garbage, you're gonna get garbage no matter what. The computer is not gonna say, "Oh well, no, I think this, that, whatever." No, garbage in, garbage out. The integrity of a program's output is only as good as its input. All right. Now, I'll give you an example. You might say, well, well, what if they put in all the data? So what's so bad about the data? Say for instance, you have somebody that always transposes the letter I in the E. All right. And then you start putting in names or not even that. Somebody when they looking at information, they always mistaken the T for a lowercase L. I'm saying they're just any little thing. And you got them inputting data. The more data they input, the more garbage you're gonna have in your computer. Because as they putting in the data and they putting in a lowercase L for the T, as many records as they put in with that bad data, that's as many records you're gonna have when you call up that data, and you're gonna have issues. Now, that issue might not come about every day, but it's gonna be that one time when somebody come in and say, "Oh, I need to do such and such and such. What is your information?" They type it in. Or say the name. What is your name? Oh, we don't have that name. Oh, yes, you've been such and such and such and such and such. I've done whatever. And like I said, until you actually go through and vet the data and look through the data and do whatever and say, oh, what's your address? What's your number? What's whatever? And compare other data related to your names or whatever, you can say, I see what happened. The name was typed in wrong, so it would never, recorded as with the right name. So stuff like that you don't want to happen, but it does happen at times. All right. So input validation is the process of inspecting data given to the program by the user and determining if it is valid. Many times you go in, it validates online. It validates a phone number. If it ain't that phone format, it's not a phone number. Most systems validate a social security number. If it ain't in the right format, it's invalid. Most systems validate almost anything, your name and stuff like that. Things that it can validate, it tried to validate. Or you should try to validate it. A good program should give clear instructions about the kind of input that is acceptable and no assumptions and not assume that the user has followed those instructions. And we do that often. What we'll do is like say, okay, I'm writing this code, push for pressure for time, whatever, or they'll understand. Oh, well, it say right here, please enter a number. Okay. To you, you wrote the program. To you, you know what data, what type number you want. To you, you know what's going to be done with that data. But then you put somebody in front of the computer, you could just go get anybody, your nephew, niece, or anybody, your parents and say, okay, run through this program for me. And it says, please enter a number. All right. And they put in 1.57. And you're like, no. It say put in a number. Well, 1.579 is a number. But it would be more specific if you would say, please enter an integer value. You understand? So now it's being more direct as to what type data is to be accepted for that particular input. All right. So it's best, like I say, it's best to be very, very clear as to what it is to be done. All right. So numbers, it tells us just here's some few examples of input validations performed by programs. Okay. Numbers are checked to ensure that they are within a range. All right. Remember, we did the range if it's greater than or equal to 20 or less than or equal to 40. Okay. If it's in that range, good. All right. So, for example, if there are 168 hours in a week, right? It is possible for a person to be at work long. Well, it's not possible for the person to be at work longer than 168 hours in 1 week. So, if somebody put 200 hours for 1 week's work, that means they stay there 24/7 every day, plus some that you don't know where it came from. All right. So that would be invalid. All right. So values are checked for their reasonableness. All right. Although it might be possible for a person to be at work 168 hours, all right, per week, it is not probable. So what happens is you may have to get with the boss or the owner and say, okay, what is the maximum amount of hours you will allow for 1 week's work? So now he might say, well, everybody has an opportunity to work 40 hours, but I do allow my my secretary to work at most 2 hours every day during the week. So that would be what your 40-hour work week plus 5 times 2, which is 10. So at most 50 hours. You got what I'm saying? So you kind of sometimes you have to do some rationales, to find out exactly what's the limitations. All right. Now, all right. Although it might be possible for a person. Oh, well, we said that. Okay. Items selected from a menu or other set of choices are checked to ensure that they are available options. All right. And what they're saying is when we ran this program, okay, when we ran this program, what are all the valid options for running this program? Well, at this point,
1 through 5.
1 through 5. Anything else would be what? Invalid, correct? So what would happen is I would have to down here, if I wanted to somewhat validate it, where I had here a CN choice, I would have to put in something like while choice is not equal to 1, 2, well, while choice is not equal to 1, or choice not equal to 2, or choice not equal to 3, or choice not equal to 4, or choice not equal to 5. You understand? Just to stay here. Something like, like this. Capital. And the not. We're gonna type. Where am I? Well, it's not equal to, okay. Well, choice is not equal to that. I'm gonna use that. I think it's choice not equal to 2. I'll just copy rather than keep running. Okay. Oh no. Well, I'm thinking the and yeah. And choice not equal. This will be 3. 3, 4. All right. So notice what happens here. So I want to stay here until it's anything other than that. So while choice is not equal to that, and it's not equal to that, and it's not equal to that, I want to stay here and do this. Okay. So when I go back and let me close this one up. All right. When I run it, oh, I got an error. Where's my uninitialized? Sure, I spell it wrong somewhere. CHOICE. CHO. Nope. What is that? Uninitialized. Oh, I need to set it. I'm comparing it, but I never set it. Okay. Okay, choice is equal to. Okay. All right. Okay, so let's debug it. All right. So let's bring it up. So if I type 8, so it's still, and see, I didn't prompt for nothing else. I'll type a 0. All right. I'll type a 7. Now I'll type the 1. So you see what happens? It stayed there. So it stayed on that right here on this choice part until, so I put in a what? A valid choice. Everybody see that? Now with the window, or not windows, with I could have made it continue and I could have put this up here while choice is whatever. I could have took this, watch, and this, but this all cosmetics also. All right, right before here. And
So Professor Sylvester.
Yes.
So is that like forcing them to only pick 1 through 5?
Correct. Validation. That's right. That's kind of like when you have to do something. They say, okay, all I want you to do is this. You validate that, hey, this is what I got. That's the right thing. Correct. You're forcing them. You're forcing them to put in the correct data. Because otherwise, if you allow users to just put any data, and even especially when you retrieving data like name, address, a phone number, and all that, and they could just put in a, and create a record. You know what I'm saying? You're just taking in data that ain't even useful, right? So that forces them. And you know what some validations are? Some validations deal with the length. All right. So like if you're inputting a number, and it could be a phone number, it might tell you input the 10-digit phone number without the characters. All right, without the dash or the parentheses or the space. Now you have to put in digits, but then you have to put in what? 10. If you don't put 10, something wrong. If you put more than 10, something wrong. So it forces you to give at least the valid format of the data. All right. So so now when I run it, I think, no, I don't have it right yet. Let's say this need to, Yeah, that's right. Because this ends here. So now, watch what happens now. And what I'm gonna do, I'm gonna add something here. I'm gonna add something. I'm gonna add this, which gonna kind of keep it clean. And I'll do a system. All right, system clear. So each time they mess up, it's just gonna refresh the screen and then prompt them again. All right. So watch. Debug, run it. Okay, should give me the. All right, so give me the screen, right? Remember before when I put in an 8 or whatever? Why it didn't clear the screen? Oh, the wrong command. My fault. I'm thinking of Linux. All right, so now let's run it. And I just want to show you. Okay, run it. Now put in a 9. So what happened? It went so fast you didn't really see it. Put in a 7. Just watch the screen. See what happened? It took the 7, but it said, okay, 7 is not valid. So it went back, it cleared the screen with the CLS, and it went back and displayed the menu right quick in the exact same place. So you really didn't see it. You understand? Everybody understand that?
Yes, sir.
Okay. All right. So like I say, until they put in, I put in a C, put in whatever. And see, like I say, character data would be any character that you put. See, if I'd have made it numeric and then I'd have put in a C or whatever, my program would have what? Would have blowed up, right? So that's why most time they change it to character, and numbers can be character, but then sometimes you have a number with more. I mean, how would I say? A number that has 5 numbers in it. So you have to read that entire string and then determine whether it's whatever. So now when I put the number 1, see what I'm saying? So like I say, that's validation. That's the simple thing. You forcing the user to put in correct data. That they're not just putting in stuff just to play around with the computer. All right. So that's what it is. I don't know who mentioned that, Miss whoever it was, but that's what it does. It forces you or forces the user to input data that would be useful or could be useful. All right. So remember we went over this program previously with the score greater than or equal to 90, greater than or equal to 70, greater than or equal to 60, greater than or equal to 70, or greater than to 60, and then anything below that was else. This is somewhat of what the program is, all right? And then what it said to validate whether or not they put in anything less than 0, you had to add that one more control. You had to have an else. So what? They put in a score, all right? But what happened? If test score is greater than the minimum, which would be what? 0, correct? And test score less than the max score, which could be, if you don't give bonus or whatever, 100. So anything from 0 to 100, now we want to check to see if they got an A, a B, a C, a D, or F. Now, if this does not hold true, remember, and if it's less than this, and this is false, and this is true, it's false still. If this is true and this is false, it's false still. It's going to go down here and say what? That is an invalid score. Now, whether it was above, below the minimum or above the maximum, you don't know because you asked all in one question, right? So, but you could tell the user in your prompt the range should be from this to this. So now what? Hopefully it'll loop back, and then they'll have to what? Input that score again. All right, so that they can calculate that record. All right, because what's happening if you're looking at it, it's kind of like we're not dealing with loops yet because that's the next chapter. But when you start dealing with loops, you'll be able to what? Like I did with that menu. You prompt the information. Hey, they didn't give the valid information. I could go back and prompt that information again. Hey, please do whatever. And I'm gonna tell you another thing. I don't know if you ever seen it, what you could do, you could put a count in your invalid loop so that, say somebody put the wrong information one time, right? Please enter whatever between whatever. So count is 1. They messed up one time. They mess up a second time. And please enter whatever. And say your trigger might be 3 if it's greater than 3. So if they invalid input is greater than 3, you could somewhat either shout at them or whatever, say, I've told you several times to whatever, and it could be whatever. I'm just making this up. I've told you several times to input a number, whatever. Please, whatever. So you try to catch their attention to say, look, you went through it X number of times. Now please put in whatever. So that, you can kind of get their attention. You know what I'm saying? So that's what you can do. You can put in that. Because in the example I'm talking about is this. If I go back to this. So say we have this. I could put a count. I could do something like this. CNT is int CNT is equal to 0. All right. So semicolon. All right. And now we know we're going through it one time or whatever. But if we was coming in and coming back from another function, we'd have to set it back to 0 before we fall in. So what'll happen is I could come in here each time I clear the screen, CNT plus. All right. So I could do this, CNT plus. But then I could also say if CNT is greater than or equal to 3, I could do something. I could tell them something. Let's see. Let me get it up. Okay. I say, please. All right, anything, you know what I'm saying? Just to try to catch their attention. All right, so what'll happen is after the third try, this will prompt, all right? And fourth try, fifth try, sixth try, you understand? Because I got greater than or equal to. So, but if I did say it equal to 3, it'll do it on the third attempt, but the fourth attempt, it wouldn't do it, all right? So watch, let's, did I put an inline at the end of that? Yeah, I think I did. Okay, and I'll do this. All right. So when I run it, so I'm valid. Okay, my menu comes up. I'll put in Y. Okay, my count change. I'll put in F. Now watch this. Put in D. You understand? Look, please view the menu and choose the appropriate choice. And as long as I don't do it, that message is gonna stay there. It's gonna stay there. So I've just after the third attempt, something they're doing is wrong, and I could even say if it was uppercase and lowercase letters for the choice, like ABC, please check your cap locks to see if whatever. So it's many different things you can do the way you program your programs, program in your code to bring forward to the user exactly what it is they need to do. So, and like I said, as long as I put in something, whatever, I'll get that. But if I do one and it's gonna go on to that, it left that up because I didn't clear the screen again, or did I? Yeah, I cleared it after. So that's just a matter of moving that or taking it out after a while. All right, and then the number, do whatever. All right. So now. And I know, let's see, what did it? All right, y'all working or y'all have worked already on chapter 4 programs? Y'all working on them? I need to go on there. Hello, class? Not chapter 4.
Working on them.
Yeah, what, okay, when they do, I think I made the last two do, right?
Yeah.
Yeah, okay, all right. So what I'm gonna do, I'm not gonna give y'all a test this week. Okay. We're gonna kind of finish up on this because there's some things you need to understand and know, whatever. And if you look at this is a condition. If x is less than 0, then y is equal to 10, else z is equal to 20. That's another way of writing an if statement. Just like that. If I wanted to do something, this is my if logic. Just writing this out. X less than this. If that's true, then I'm setting y to equal 10. If it's not, I'm going to set z to equal 20. And that's, look here, that's equivalent to writing it this way. So, and like I say, all that's programmer style. That's all it is, programmer style. But like I said, I need to go over those character data. I'll go over that. I don't know. We should be close. Yeah, we a little bit. And then the switch statement, case switch. We won't write code with the switch statement, but I can show you how it works. Well, you got it in the book too. It shows the case statement. What happens is you declare a variable, or you have a variable, just like our menu. We had our menu with 1, 2, 3, 4. Then I could say switch choice. Okay, switch is a command in C++. Embody my switch in curly braces. Case, in our situation, this would be case 1. Because remember, this is char data, right? Remember, I had 1, 2, 3 as char. So I'll say case 1. Okay. And what I would put here is that call function. And that call function will go and execute that add number of function. All right. Then I could have case 2. And notice what? There's a break. Now, if you don't do the break, what'll happen is it'll do this one and it'll do this one, even though this one was the true one. Okay. It'll do everything until it see a break. So if you wanted to do something based on the choice being 1, or in this instance, A, you do whatever. You can have many statements, semicolon, hit enter, have another statement, as many statements as you want, but then break. And then it'll kick out and continue with the program. All right. If it's not A, then it'll check and see if it's B. If it's B, then I'm going to execute so many statements or whatever, and then break. And then if it's not A or B, if it's C, then I'll execute whatever statements and then break, allow me to break out. But if it's not A, B, or C, or I could have 15 different choices, characters that I'm checking. But if it's neither one of them, then it'll do the default. You didn't enter the right value. So I could have used a case statement rather than the while statement, all right, to do the same thing I did with the menu, all right? Could have did the exact same thing, all right? But I don't want to hold you up. I know other people have classes and whatever, but we'll continue on next class period. And after next class period, I will give you a test. Work on your programs, get these programs done, I guess, when it's tomorrow, right? Tonight or tomorrow, get them done. And then we'll finish this up. I'll give you, I'll announce the test. And then we'll start with loops, all right? We'll start with the loop, while, the for, while, and the do while. And do while, do until. All right? Any questions? Anybody with any questions, concern? Everybody sign the roll? All right.
On the roll.
Huh?
What's on the roll?
All right. So if there's no questions, going once, going twice. All right. I'll see y'all on next class period. But keep on studying, keep on reading through the material, all right? Because don't just put it down. You gotta go through it. Even if you gotta type in some of the programs, just a little you ain't gotta spend all kind of time, just a little time every day, every other day, and doing stuff, you'll be all right. Okay?
Yes, sir.
All right. So I'll see y'all on next class period.
All right.
All right.